In this video, I'll examine what is meant by reducing a fraction to its lowest terms or its simplest form and the techniques for doing so. First of all, let us look at what we mean when we say that a fraction has been reduced to its lowest terms or that it is in its simplest form. Let us look at an example, say 2 over 3. Here the numerator and denominator don't have any common factors other than 1. We call such a fraction as being in its simplest form, or we say that it has been reduced to its lowest terms. Let us look at another example, say 4 over 6. Here the numerator and denominator are even numbers and hence are both divisible by 2. We say that this fraction has not been reduced to its lowest terms or it is not in its simplest form. Or take 6 over 9. Here the numerator and denominator have a common factor of 3. So even this is not in its simplest form. Let us now examine how to go about finding out whether a fraction is in its simplest form, and if it is not, how do we go about reducing it to its simplest form. For that, let us first look at the visual representation of the three fractions on the board. The fraction 2 over 3 can be represented by taking a whole, dividing it into 3 equal parts and shading 2 of those parts. For representing 4 over 6, I need to take a whole and divide it into 6 equal parts. For doing this, I'll first divide the whole into 3 parts as before, and then divide each of the 3 parts into 2 equal parts, getting a total of 2 times 3, that is 6 equal parts. I need to shade 4 of these parts. Four is the same as 2 times 2. Compared to the visual representation of 2 over 3, we have doubled the number of parts that we have divided the whole into, and also doubled the number of parts that we have shaded. So we are looking at smaller parts but more of them. So 4 over 6 is the same as 2 times 2 over 2 times 3. Visually, we can see that this fraction is the same as 2 over 3. For representing 6 over 9, I need to take a whole and divide it into 9 equal parts. I'll achieve this by first dividing the whole into 3 equal parts, as in the case of 2 over 3, and then dividing each of the 3 parts into 3 equal parts, ending up with a total of 3 times 3, that is 9 equal parts. I need to shade 6 of these parts. Six is the same as 3 times 2. Compared to 2 over 3, here we have tripled the number of parts that we have divided the whole into, while also tripling the number of parts that we have shaded. Again, visually we notice that 6 over 9 is the same as 2 over 3. This is not surprising considering the fact that these are all equivalent fractions. Since multiplying the numerator and denominator of 2 over 3 by the same number 2 gives us the fraction 4 over 6, it is obvious that dividing the numerator and denominator of 4 over 6 by the same number 2 gives us 2 over 3. Again, multiplying the numerator and denominator of 2 over 3 by the same number 3 gives us the fraction 6 over 9. So it is obvious that dividing the numerator and denominator of 6 over 9 by the same number 3 gives us 2 over 3. We say that the fractions 4 over 6 and 6 over 9 have been reduced to their lowest terms or their simplest form 2 over 3. So to reduce a fraction to its lowest terms or its simplest form, we need to find a big enough common factor between the numerator and denominator, such that after dividing them by this common factor, the numerator and denominator have no other common factors other than 1. As we know, Such a common factor is called the highest common factor, HCF, or the greatest common divisor, GCD. So given a fraction, we need to find the HCF or GCD of its numerator and denominator. Once we have this, all we need to do is to divide the numerator and denominator by the number we have found. Let us now take an example to see how to do this. Say we have the fraction 130 over 330. We need to find out whether this fraction is in its simplest form, and if not, we need to reduce it to its simplest form. We can see here that both the numerator and denominator are even numbers and hence divisible by 2. So obviously the fraction is not in its simplest form. But how do we go about reducing it to its simplest form? As we saw, we would need to find the HCF or GCD of 130 and 330. Taking out 2 as a common factor, we get 65 and 165. Both these numbers end with 5, so 5 is a common factor. Taking out 5 as a common factor, we get 13 and 33. 13 is a prime number and 33 is not divisible by 13. So there are no more common factors and we can stop. The HCF or GCD is 2 times 5, which is equal to 10. So we divide both the numerator and denominator by 10 to get 13 over 33 as an equivalent fraction in its simplest form. Instead of finding the HCF or GCD formally, we can also divide the numerator and denominator by the common factors progressively, reducing the fraction to its equivalent simplest form. Let me write down the fraction 130 over 330 again. Dividing the numerator and denominator of 130 over 330 by 2, we get the equivalent fraction 65 over 165. This is still not in its simplest form. Dividing the numerator and denominator by 5, we get 13 over 33. There are no more common factors and hence we stop. It is easy to see that we are doing the exact same thing that we did when we found the HCF or GCD formally and used that to reduce the fraction to its lowest terms. In the case of our fraction 130 over 330, it is easy to see that both the numerator and denominator end with 0 and hence 10 would be a common factor. So instead of dividing first by 2 and then by 5, I can divide the numerator and denominator by 10 instead, ending up with 13 over 33 as the equivalent fraction in its simplest form. Now that we know that we need to divide the numerator and denominator of a fraction by its common factors till we have no more factors left, the question arises, how do we know when to stop, or how do we know when we are run out of factors? I cover this aspect in another video. If you found this video useful, be sure to like this video, and if there are any fraction related concepts that you want me to create a video on, please leave your suggestions in the comment section. You can also consider subscribing to my channel for more such videos. Thanks for watching.